let's talk about two important definitions before we go forward on this into the study of chemical equilibrium. We'll be looking at what reversible reactions are. Let's read the definition. It gives us a reversible reaction is a chemical reaction that can proceed in both a forward and reverse directions. Oh my word, what is that? In other words, the reactant and product of one reaction may reverse roles. Okay, so what does this mean? Well, let's bring up a white screen quickly. And let's talk about these reversible reactions. Let's say I have A plus B, and that gives me AB, right? We'll just leave it like that, but it is balanced. Now, the first thing you need to note over here is a set of double arrows. That represents a reversible reaction. Okay, it is sort of like a shorthand to show me that these two reactions go both ways, right? The reaction that goes A plus B, and see that I'm drawing it with one arrow, gives me AB. This is known as the forward reaction. This is known as the forward reaction. It is the reaction in which the reactants create the product. And this one over here, if I go AB, gives me A plus B. This is known as the reverse reaction. This is where we take the product and it really becomes the reactant and forms a new product, which used to be the reactants, right? So this is going to be the reverse reaction. Okay. So I've got A plus B gives me AB, right, which is the forward reaction, and then I've got AB, which goes the opposite direction, gives me A plus B. This is really a reversible reaction. Now, what in the world does it mean? In the next video I've actually uploaded, it's not my own video, it gives you an entire example of a process known as the Haber process, or making of ammonia, which is really a reversible reaction. It tells us that when I have, for example, I've got a nitrogen molecule or atom, and it comes together with a hydrogen atom, and they form together, they make ammonia. Now, what happens in a reversible reaction is that these two molecules will come together, they will make ammonia, but because it's reversible, it will break up and it will form the reactants again. That's what happens in reversible reaction, right? Righto. So let's just bring this up again. I've got A plus B. That's what a reversible reaction is. It goes both ways. Okay. So let's just take that there and let's get the white screen going again. Okay, that's a reversible reaction. Can proceed in a forward direction and a reverse direction where the products can become the reactants and the reactants can also become the products. Okay, now we talk about types of systems. Well, we get an open system and we get a closed system. Now this is going to be quite important because the section we're going to be studying, known as chemical equilibrium, can only happen in a closed system. So we need to know what exactly a closed system is. Firstly, let's talk about an open system. An open system is one in which the matter or energy can flow into or out of the system. Okay, so this is matter in or matter out, and energy in or energy out. That's open. Anything goes. Okay. Then the next one is a closed system. Well, a closed system is one in which energy can leave or energy can enter, but the matter cannot. That's very, very important, and I suggest you take it down, write it down, engrave a neural pattern. Okay, definition. An open system is one whose borders allows the movement of energy and matter into and out of the system. A closed system is one in which only energy can be exchanged but not matter. Now, what's not on the slides here is what we call an isolated system, and let's just add that quickly. I'm going to give you the definition and you can take it down. Okay, I'm going to give you the definition. An isolated system is one in which it is really the opposite of a closed system. It means no matter in, no matter out, and no energy in and no energy out. Okay, so no transfers of energy or matter. Okay, and that's really what an isolated system is. So there we've gone over the key definitions. A reversible reaction is one that can proceed in both ways. The products can form reactants and the reactants can form the products. Okay. Very importantly, if I ask you to write down the forward reaction, you only write it with one arrow. And if I ask you to write down the reverse reaction only, then you also only write it down with a single arrow. If you are writing down the reversible reaction, you use double arrows. Okay, open and closed systems, matter in, matter out, energy in, energy out. Closed, only energy can transfer but no matter, and an isolated system is simply the opposite of an open system.